So for stereochemistry, you have 4 unique substituents attached to a single carbon. Priority is based on the atomic number given. If it's clockwise, it'll be R. If it's counterclockwise, it'll be S. And finally, if the 4th substituent is facing out of the page, which will be a wedge, then you have to flip your answer. So if you got S, then it'll become R. If you got R, it'll become S. So let's see some examples. So this one, right, it fails the first rule of stereochemistry because you need 4 unique substituents, and this one, all of them are the same. So this right here, this carbon is not a stereocenter. Moving on, this one is still not a stereocenter, right? Because we have two carbons that are exactly the same. So you need 4 unique substituents on the inner carbon, and so this also is not a stereocenter. So moving on, this one actually is, right? Because we have 4 unique substituents on the center carbon, so then this would follow the rule, and then this would actually be a stereocenter. So you can have stereochemistry on this one. So for this one, so whenever you have a ring, right, this is technically 2 substituents, but no matter which way you go, right, it's the same because there's symmetry. Because if you go this way, it's the same thing, and if you go this way, it's the same thing. So because of that, these 2 substituents would be counted as the same, and this would actually not be a stereocenter. So if you move on to this one, though, this one is a stereocenter, right, because of this methyl group. So let's look at this substituent right here, right? As you go, right, these 2 carbons are the same, and then, but as you get here, right, as you go here on this side, you encounter a methyl group. And that's not found on this side, right? So this substituent is actually different from this one, right? Because it takes longer to get to the methyl. So in this case, this carbon would have stereochemistry. So the first example of actually doing it, so you start at your center carbon and you look for the highest atomic mass element, right? So in this case, we have hydrogen, oxygen, carbon, carbon, and then so obviously oxygen would be the highest atomic number, so then that would be 1. So then moving on, we would look at the other carbons, right? Because carbons have a higher atomic number than hydrogen. So we look at this carbon and write it out. So this carbon has 3 substituents, and it'd be 3 hydrogens. This carbon also has 3 substituents, right? And so it'd be carbon, right? Because this carbon is attached to another carbon right here, and then it's attached to 2 hydrogens, right? Because the hydrogens are always implied. So now we just compare which one has the highest atomic number, and you can see that this carbon wins because there's no hydrogens, and since carbon has a higher atomic number, then this would be number 2. And then this would obviously be 3, and then finally 4th would be hydrogen, because hydrogen has the smallest atomic number. And hydrogen will usually always be 4. Now the final case, right, if you remember, it says if the 4th substituent is facing out of the page, then flip the answer, right? So let's look at it. So in this case, it's actually not, right? Because the OH is facing out of the page, right? So if the OH is facing out of the page, that means the hydrogen's facing into the page. And since it's facing into, we don't have to flip it. So now we just look at the actual pattern. So we start at 1, and then just ignore 4. And then just go whatever direction the numbers are, right? So 1, 2, 3, right? So I'm going this way, and that way would be counterclockwise, right? So then it would be S. Because as the rule suggests, if it's counterclockwise, it's S. So going back. So all I did here was just look at the atomic numbers, right? Look at the atomic numbers, say that this is 1. Look at this. Label this carbon, say that it's attached to another carbon, 2 hydrogens, over here 3 hydrogens. This carbon will beat this hydrogen, right, because it's a higher atomic number. This will be 2, this will be 3, and then finally hydrogen will be 4 because it has the smallest atomic number. And it's not facing out of the page, therefore you don't have to flip the answer. And then finally you just look at the numbers, so 1, 2, 3, and it's going counterclockwise, and so it would be S. So moving on to the next example, we do this again. So we look at it with hydrogen, OH, carbons. So in this case, right, if you compare it to the last one, it's actually the exact same, except that I flipped the dash and the wedge, right? Now the hydrogen is facing out of the page. But once again, it would be the same pattern, right? So all I did was 1, 2, 3, 4, right? Everything's the exact same. The method of how I got these numbers. The only thing that changes is that since the fourth substituent, which is hydrogen, is facing out of the page, we're going to flip the answer. So we got S for this answer, right? So all we do is just get S and then flip it to R. So that's all you have to do if the fourth substituent is facing out of the page. So moving on to the next example. So we identified that this is a stereocenter, right? Because it has 4 unique substituents, because all these are different. If this looked the same as this, then this would not be a stereocenter. But in this case, it is. So we can start. So chlorine has a higher atomic number than fluorine, so it'll be 1, and this will be 2, right? Because these are just carbons. Now looking at the carbons, we write all of its substituents, right? So for this one, we'll write carbon and then all of its substituents. So this carbon is attached to one other carbon, and it's attached to the implied 2 hydrogens. And over here, this carbon right here is attached to 2 carbons, right? And then it's attached to a hydrogen. So if we look at the first element, the carbons cancel out, and then the second element, this carbon wins, right? Because it beats the hydrogen. So then therefore, this would be 3 and this would be 4. So now we look at it and say 1, 2, 3, right? But the thing is, in this case, we don't know if the fourth substituent is facing into or out of the page, right? It's in the plane of the page. So what do we do in this case? Well, in this case, you have to rotate it, right? So in this case, if you imagine like a pencil, right, sticking into this molecule, and then if you turn it, right, if you turn it left, or if you turn it counterclockwise, right, if you turn this entire molecule on a pencil, if the pencil is sticking right through, and if you turn it counterclockwise, clockwise, right, if you're turning it clockwise, the Cl will be in the plane of the page, the F will be in the plane of the page, and now this carbon group will go into the page, and this carbon group will face out of the page, right? So all I did was just imagine sticking a pencil through this molecule and rotate the entire molecule clockwise, right? So then the chlorine and fluorine will be or in the plane of the page. This will stick inward and this will stick out, right? So now since we know the stereochemistry of the fourth one, right, it's facing into the page. Now we can do 1, 2, 3 and just look. So 1, 2, 3, it's going this direction. So it's going clockwise, so it will be R, right? Because the fourth one is not sticking out of the page. Therefore, we don't have to flip it, and therefore we can keep it as R. So that's the last example, and I hope that helped, and thanks for watching.